This is Serena Shanko, and I am going to present the communication exercise. I'm in the Tuesdays and Thursdays class from 8:30 to 8:45. So the question reads, just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. Everyone said that they saw it coming. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what's the time of death? So the first step that I always do before solving these type of problems is to name the variables. So your temperature would be 75 degrees, temperature ambient, or the temperature of the room is 70 degrees, temperature of the object is 80 degrees, and the K and the time is unknown. The second step would be to find K. So we use the formula T equals T ambient plus T object minus T ambient times E raised to the K times T. So from the values we found before, you just plug them in. So 75 equals 70 plus 80 minus 70 times E raised to the K times 1. So the first thing you do would be to subtract 70 from 75, and that would give you 5 equals 80 minus 70 times E raised to the K times 1. And then you subtract 80 minus 70, and that will give you 5 equals 10 times E raised to the K times 1. And then you divide 5 by 10, and that would give you 0.5 equals E raised to the K times 1. Because you need both of the bases to be the same to go any further, you would take the natural log of 0.5 equals natural log of E raised to the 1 times K. And the natural log of E is just 1, so that would just equal natural log of 5 equals 1. And then you would just take the natural log of 0.5 and divide it by 1, which would give you negative 0.6931471,806. The third step would be to find the time elapsed from time of death to discovery. From last time we found our decay coefficient, and that was the negative 0.693, so we use the same formula to find our time elapsed. In this case, we plug in 80 equals 70 times the temperature of the object before the death, which was 98.6, minus the temperature of the room, 70, times E raised to the negative 0.693 times T. You subtract 80 minus 70, which would give you 10 equals 28.6, and we got that from subtracting 70 from 98.6, times E raised to the negative 0.693 times T. And then you divide 10 by 28.6, which would give you 0.3965 equals E raised to the negative 0.693 times T. Once again, we take the natural log of both sides to get the same base. So the natural log of 0.3496 equals the natural log of E raised to the K times negative 6.93 times T. And then you would take the natural log of 0.3496 divided by negative 0.693, and that would give you approximately 1.5 hours. The fourth step would be to approximate the time of death. So originally we found him dead at 6 p.m., and from the last step we found that he died 1.5 hours prior to that. So 6 p.m. minus 1.5 hours is 4:30 p.m.